Hello, good evening. Welcome to Code Night ANZ. And tonight we have a special guest, Andrew Rickard. How are you?
Yeah, good myself. Yeah, thank you. I'm all good.
Yeah, wow, it's interesting. So for you like that don't know Andrew, so we are colleagues at Arinco, and we work in different engagements. But what's interesting is that Andrew have been exploring AI harnesses and spec-driven developments, and he's got like a really good concepts and a framework that he's been working for some time. And yeah, so you're talking about like agents, harnesses, memory, and
Yep,
context, Andrew.
yep.
Well, could you bring like a teaser to the attendees?
Yeah, I probably would. I could introduce a new tool that I actually just launched on NPM last night. And there's actually a visualizer rather than a chat interface to AI or a model. It's actually visualizing a, uh, the LLM thinking.
Wow, yeah, that's cool.
So I'll give a teaser at the start. And if we have enough time, I'll show a bit of a demo at the end as well.
That's cool. I always enjoy like your demos, Arinco, and I'm excited for that. And the audience is going to be excited for that as well. You definitely bring in like the latest and greatest. So yeah, so hang with us. And before like we get started, Andrew, I'm just going to introduce the user group. So if you're here like coming from the first time, you know that like we are Code Night user group. We're a community group of developers. We love coding. We follow best practices on software development languages and technologies. In general, we tend to talk more about the Microsoft stack, but we're open to all technologies. And we have a purpose. So we come in here like to enable developers with practical knowledge to excel and launch their careers. You're always going to find like great content with us if you're starting or as a software developer, or if you're a technical lead. You're going to find something useful for what you've been doing. We're also like part of AzureTire.com. We're a group of cloud native enthusiasts, and we get to share like the latest and greatest in the cloud native space. We're sponsored by .NETFoundation.org, which is the entity that looks after the different open source .NET projects, and JetBrains, software tooling for developers. With no further ado, Andrew, I can bring your slides, and the floor is yours.
Cool. I'll start the drive. But yeah, hello, my name's Andrew Rickard. I work here alongside Marcel from Rinco. And yeah, I'm an AI consultant engineer at Arinco doing all things AI. I might kick off. And I
Yeah.
mentioned I was going to do a bit of a teaser.
Yep.
Bear with me. I'll just do. Just getting my screens ready.
No worries.
Cool. You should
Here we
see my
go.
screen.
Let me just bring that in. Cool.
So this is actually the tool I'll finish at the end. It's called Clinky, which is about visualizing. So I just put this prompt in just before, and what I've done is I've actually just saved the session.
Yep.
So
Yeah, I can see a lot of tasks and sounds.
these are actual thoughts. Well, so the prompt was I need to prepare presentation. This is the thoughts, and if we sort of look behind it, there's a whole categorization layer here. And this isn't the focus of my talk tonight, but I just thought I'd mention it because it's quite cool, and I might circle back to it. But this is, I just released this to NPM last night. I'll send you the link in a second, but I just thought I'd mention that because it's a bit of fun.
That's cool.
Just fine here. Just see my screen again. You can see that's that keynote.
Yeah, you're there.
Yeah, all good. Cool. So I just wanted to, that's not really a slide heavy. I just wanted to sort of whiz through these and provide some context around these sort of broad topics. And that term, which I found it's sort of incoming in popular usage, but that term, an agent equals the model plus the harness, which I find quite interesting. It's a good, insightful take. And it's maybe a tiny bit small, but the guy from LangChain has got a very cool quote about what is a harness, and it's like all the pieces of code configuration. It provides, you know, the loop, the feedback mechanisms that takes turns a raw model into something useful. So he's got quite a good diagram for like the harness, which you can, if we go back, it's really the agent equals the model and the harness. And we have all the component parts, the context, the control, the actions, the file system integration, the observation, and the verification layers, all a part of the harness. And then a Bridget from ThoughtWorks, who's associated with like Martin Fowler, did a really good diagram around this, the topic of harness engineering and for coding agents. And she introduces this really, to my mind, really interesting idea of guides and sensors, or feedback, feed forward and feedback. So at the top, we have the bit that we can, the guides are typically what the things we can build out as we're giving information to the model. And so that's instructions. We can call CLIs. We can make it call out for skills or call out language servers. And what that's doing is it's guiding. So when we're instructing the agent to produce a particular outcome, we're feeding it forward or guiding it. And then once we've got with the contents being generated, then we can feed back. So we can do logs. We can have an agent review particular code. We can do static analysis if it's code. If it's browser, we can do screenshot verification. And if we sort of summarize that here in the guides and the instructions in feed forward, these are the things that, yeah, I was saying, it steers before it acts. So instructions, docs, skills, all the how-tos. And these also can be tools where we can call out to a CLI to like shape the particular or give more information to the agent as it's creating the actual output. And then we have the feedback. And then so we can have, and you have noticed when you're working with agents, it's doing that all the time. It's, you know, it will either lint or it'll automatically run tests, or we can tell it to run tests. But there's an overlap sometimes with like the feedback. We can get automated feedback as we're generating, but typically the generation will happen after the feedback will happen after the generation is completed. These two constructs, as in the feeding forward and feeding back, I think, to my mind, the sort of the interesting and insightful point from this article, and I'll share the link, is that idea that we're responsible as engineers and AI engineers, that where we drive this, we're the ones who are providing the feed forward, the guiding information, and then we can control and help control the sensors when we're feeding back. And so if we take this sort of those two constructs, and that's what I was around to like the user harness, is in that's what we build. We're building out the skills and the instructions and the CLIs, and then the pipelines where we can run the feedback back into the agent. And then the builder harness, which is like, you know, the builder that's actually running it. And so all of these here, like this is Claude Code, or it's Copilot CLI or Copilot Chat. But all the harness have got the different layers. So in green, it's what I would use the words we control. The builder, it's what the vendor provides. And then the model is obviously just doing the reasoning and the deciding. And so I would just to put in an Agile lens, And I just thought I'd sort of whiz through over the key at the moment Azure type. In this term now it's a platform, but some of the ideas still apply. Like Foundry, obviously it's the pro code that it's providing the catalog and the toolbox. So it's providing that builder harness, even though it's a platform. Conceptually, it's the builder harness. And we provide the instructions. We can provide right tooling where we provide the feedback and the feed forward, and then we provide the orchestration logic. And then going down the tiers, we have lesser control, but just as powerful, but lesser control. The Copilot Studios, as you know, is like low code. We can do the harness, we can do the guides and the instructions. We can inject tools and connectors to feedback into the generation, what's being generated by the particular agent. And then the 365 Copilot is less capable in the sense that we can provide the guide or the feed forward, but less so the tooling. I thought I'd just mention those ones to put it into like context of that in here, this is like Copilot CLI, and that the overarching harness has its particular layers. Same essence in the Azure platform sense. It's this conceptually, it's a similar thing, that there's layers providing different pieces of functionality, and we as engineers, we write and control parts of it, and then the other, we just make usage of the platform itself. So I'm going to stop sharing and I'll come back to here. Just bear with me. There. And I'll do here, I'm going to test the demo guide. So I've got VS Code, what I want to do, I've got two VS Codes. I'm going to put in a prompt. And then I've got another VS Code. I'm going to put in a prompt. And if I'm lucky, we should get, yeah. So we're getting a response back. This is there's Microsoft, it's a product Orchard CMS, and it's just a legacy old-fashioned CMS. It's like NetCore, not even NetCore, Net something, I even forget the stack, but it's basically old. And like, as weird a Rinko, but I think everyone at the moment is also interested in around like app modernization. I'm using this as an example of like app modernization as a candidate for automating to have an agentic workflows to modernize these. And so what I've done here is I entered a prompt in, and I got pretty good, detail of the relevant the repo. And if I switch back to the other one, the model's sort of a bit unsure, but it now is asking me about the life cycle. So in this case, it's smart enough it doesn't understand the code bases, so it's just asking me a question. So I'll just say 1 for like the request life cycle. And so here, if we can see that as we're tracing, it's now exploring the code base. And it's, it's doing like a grep, it's trying to find files, it's trying to get the context, the information. If we go back to here, this one here, it probably, I think it didn't even hit the file system, the code at all whatsoever. But if I do to like this B, here, and it's still going. And so now we're burning up tokens. And as we know, I think we're all aware of like the ever increasing cost of tokens, and it's going to get much as the different the less subsidized token usage is going to come in. Token management will be definitely a useful skill to have. And I'll just sort of cut to the chase, but here for me is a perfect example of what we want to avoid, and what some of my lessons over in the last. I'm just going to let this run along. I'm actually going to show, this is my repo. And I did a project over the Christmas break, last year, this year. And it was, I make electronic music. What I want to do is I want to make a online mixer that you can play. I don't think you can hear that, but it's a way you can actually mix music and then put effects on it, et cetera, et cetera. And I'm not here to talk about that, but one of my lessons in the way I work is I tag team model. And what I mean by that is when I was developing this, working alongside Claude and Gemini, I would actually go, I need to add a feature, make me a plan, and I'd get Gemini to review it, or vice versa. Or I'd get Claude to write out some code, and then I would get Gemini to PR it and to give feedback. And one of the other, what I need to do that, I need to be able to share the information, because it's a pain to, go from one chat session to another. So what I did here, I produced this is manually, a whole lot of detailed documentation, which was like awesome, because this is quite a complicated project. And what it was doing is it's defining all the information about this online mixer. And the details of it, I don't think are that important. But what's important was that over time, and working alongside for weeks at the time that I spent, that each of the particular the agents, Claude or Gemini, could be like, they're not stateful, but I could start them again and automatically they would have context, automatically they'd have understanding. And so when I would say, we need to work on the peak generator, the first thing they would do is come to this file. And then I wouldn't have to go, the peak generator is about this, etc. And so that understanding of needing to provide context drove the creation of the tool that I wrote, which is effectively an agent. And when I'm same as Marcel, we're consultants, so we come into an engagement with a client. I had one recently, a big financial organization, and they have legacy code bases, and this one was pretty good. Like the coding standards were really good. It was a very, very large repo, but it was really well structured. But what it lacked in, it didn't have, the README was rudimentary. It didn't have any context information about it, how everything worked. And so some information would have been in developers' heads and in emails, etc. And so what I typically do when I come on board is I would do like a prompt. Write to me, review the code base, pull out architecture documents for me, and so I can understand it. Because I'm lazy, I don't want to have to go through all the code. I just would like to have a high level understanding of the actual code base itself. And so what I did at recognizing that is came up with like a framework. And it's really just like this is like light touch. It's quite simplistic. Is we have agent instructions, so the agent's MD or Copilot instructions. We have the architecture docs. And then the other one is introducing is the agent decision context, which is it's analogous to an ADR, but I regard it as different because it's capturing the why and the reasoning behind a particular change. So often an ADR or architectural decision record will debate and structure a particular architectural decision, but not all the other things that have been considered, and it might not be associated with an execution plan. So go back to that the online mixer that I did. I would get Claude or Gemini to make me a cool plan and say, hey, I need to introduce this feature, and I'd get it reviewed. But then I'll throw away that plan, and then a couple of times in development, the Claude or Gemini go, hey, let's do this, and I would go, no, but we decided that we weren't doing that because of particular reasons. And then the delta was, and that's what made me realize the benefit of these saving plans, is it's long-term memory for the agent. if you have a repo or project where you investigate or you do authentication or using a particular auth mechanism, and you make a decision to say, no, we're going to use this, authentication A over authentication B, you don't want the agent 6 months from now to go say, hey, have you thought about authentication B? Because we've already decided that. So that's some of the things that the agent decision context is around, is saving them long term, saving the decision. And so in an agentic workflow, an agent can then read those files and go, we made a decision, and then we decided not to do those particular things. And so I sort of gloss over here, but basically what I made, it's designed to be cross-platform, so supports sort of the primary popular agents. And it is just a big prompt at the moment. It is just an agent. And so if we look at Claude, but they're all identical. The only difference is the front matter. So, Codex, I'll just show you. Codex has got a slightly different here. So Codex, see the tooling is a bit different because they're all a bit different in tooling. But below here, they're all exactly the same. And so really what it's doing, it's generating the particular documentation. And I won't go through this, but you're welcome to read the repo. But it's being really, really specific. It's being really quite precise. And one of the overarching ideas of ACF is consistency, that all of the architecture overviews are always the same format. The documentation that's produced has a similar structure. And then the agent's MD that's created, again, has a similar structure. So for a large organization and you've got 100 repos, in my mind, it doesn't make any sense to have differing documentation approaches per repo. ACF promotes that idea of standardization. So
I got a question, Andrew. Sorry to interrupt. So you mentioned about these concepts of the feed forwards, where you have your agent, MD, your documentation, and the feedback where you validate what's being produced, maybe having linters or tests.
Correct.
But you're mentioning about memory, right? So you're bringing this context with those decisions, right? ADRs in there.
Correct.
So that's what you have baked in within this
100%.
sort of framework.
It's that idea, and that's sort of a good, perfect pivot point, Marcel, to go to run this. I've just got a script, and so I've just got all the agents, and then this just calls out the model, passes in the, and then it's all CLI, so Copilot CLI or Claude CLI, and it's just running through the 5 stages of ACF. And so what I mean by the main 5 stages is this. So stage 1, we onboard, we do a high-level summary of the code base, and we produce the architecture overview. We haven't looked at every code file because we don't need to. And then what we do is we do verification steps. And then now I'm going to pivot around to feed forward and feed back. So I had version 1 of this ACF. And I wanted to prove, I wanted information. Does it really work? Does it use less tokens? Is it correct? And so what I wrote was a script that downloads a repo from GitHub and runs ACF against it. Runs all these steps here. And then once I've got that data, I use a model to analyze it and say, well, it's written documentation, it's written agents MD pointing, is it true? And what I got a vast amount of data. And so I actually did a blurring of the lines of feed forward and feed back. So what I would do, I would run the analysis, and we can see it here. It's this particular batch, and it's identified that some of the documents have got errors. And then what it does is then it talks about the classification of errors, which I'd like to come back to because I think it's really, really useful. But this tool that I wrote was helped me identify that I had one of these verify steps. But what was happening is an error could get propagated. And also, what I was discovered that an agent in a session, like you'd be aware of the term context rot. That the more information you give into the context window, the LLM becomes less accurate because it's so much context. It's losing specificity. It's losing the exact details. And so from building out that tool and the feedback and the feed forward, that what I needed to do was use a completely different model. So this is like Sonnet, that's Opus. Sonnet, Opus, and ChatGPT or 5.5. But the critical nature of it was to use a different model, and that was my deep insight. And so what I could do was I could make change to the prompt, the agent, with all these instructions, and then I could run the tool again. I could see the effectiveness of the changes that I made, and then I did rinse and repeat. I would do it again, and I get fairly obsessive on things, and I run hundreds and hundreds and hundreds of tests on it. And to my mind, it really that feedback and feed forward. Sometimes I'd let it. The agent automatically update the ACF agent, but often I wanted to be in the driver's seat, and I would turn that flag off. I'd actually go, make changes, but I want to be the arbiter to go, okay, this is what we will change. But that idea of writing a tool that's validating, and I did a presentation at a Rinko internal one the other day. And some of my sort of lessons is write tools, not prompts. Write tools that actually validate what you're doing. If you're putting an output, and if the cost of producing code is relatively, I don't mean cheap, but we can use an agent to produce the code. That means then that we've got time to then provide, increase that feedback and feed forward. And write Python scripts or a shell script or whatever technology you'd use to validate the output that you're doing. And that idea applies to like a coding agent when we're using it to produce code. But semantically, I don't think it matters at all. Like I've been doing an internal assessment of an Azure integration platform, and I would use AZ, the CLI, to query Azure. And then I would make a report, and then I'd actually got a Python script that would validate the report. And again, that's like I got an agent to read some of the data, but I validated. I wrote a tool to validate that the agent was correct, that it wasn't hallucinating. And so to move on here around that idea, sort of halfway through. I just want to go, I'll jump back to the ACF in a second, but I'll show you here. So when I was building out that tool, the testing harness, all errors would become, very, very common. And I just sort of grouped the top 13, which I'll go through, because I to my mind, I think it's very useful as in that we're like we're part of the user harness of the tool. And so we can write the instructions, we can write the tools and the linters. But also what is very useful, I feel, is an awareness of the fallibility of the model, the way that they behave. And so, like I would assume, everyone knows that LLMs can't count. And so I would get that in that tool that I wrote. I would get them again and again and again and again and again. And so I've just got examples in here, and I'm happy to share this file, where the LLM they estimate. They'll look at, enums, there's 10 enums, but there's actually 12. Or there's so many steps in a workflow. And so like here, there's how many API, and this is all real data that extracted from the tool, is how many API controllers are in the project. It said 5, but because there's 2 controllers didn't follow the same pattern of entity, it ignored them. And that's sort of like a counting error, but it's also an inference error. And same as like this one here, the bicep one, where we want to see how many policy definitions are. It didn't. There was a. It just did a grab. It just did a count of all the files, but it didn't bother to look that there was a text file in there, and that's not a policy file. And so my lesson is what we need to do is we need to enumerate those values. If it says something once in the verification, count it again and say, is that, not prove that it's actually that count is correct. And I won't go over all of these at the thing, but I would go that my colleague was showing me one that this exact thing happened. It fabricated file path. It will just make up a file name. It will go, oh, I think the file name is this. And so he was getting a build, like a model error. It was looking for a particular file that didn't exist. And again, that the training of the LLMs is so strong that they will just look at a file and they will assume that that's what the file name is, or they'll read great meaning to the name of the particular file. And I'll sort of go one before, like here, the LLMs will use words like every or all or always or never. And again, it's just it's rounding up. It doesn't actually, it hasn't checked everything, but it will say all, every, in this example here, every module in the Bicep project has that. And then actually 4 modules don't. So it was completely incorrect. And I'll do here, and these are my 2 favorite ones, behavioral fabrication. And then there's another one, convention inference, but they mean they're very similar. Is the training of the training data of the model is very, very strong, and so it will just make an assumption to go, based on a particular name of a file, it will then assume that particular behavior exists. So in this case here, the method was called, the saving chains interceptor, and it incorrectly wrote down in a document sense, it incorrectly identified the wrong behavior. And because it didn't look at the code, it actually just went, this file, this has got that method, based on its names, I think it would be, save changes, which is incorrect. And then the similar one is convention inference, where it'll make an assumption. It'll just go, I have in this example here, there's like a particular a message event type, and it will just infer not the behavior, but the way that the particular code works. And so it doesn't even, in a way, it doesn't look to the code. It just goes, I think this is how it works because my training data, it says 9 times out of 10, it's like this. So that's the convention. And then here for me, like the Bicep one is like I'm not a huge PowerShell user, but I would get this error again and again. The add member, basically there's a weird flag to it without force. Duplicate property names are silently keep the first value, as in the behavior is different if you don't provide this parameter. But what the LLM was, it inferred that based on its convention, based on its training data, it just assumed that was a particular way that the particular code was working. And so again, in like that tag teaming, I put these errors into Gemini and said, what about these? And then Gemini said, that's senior developer arrogant, which I thought was hilarious. And it's true. It's like, you'll come into an engagement, you'll come into like a repo, and there's like, it's web API or MVC or this or that, blah, blah, blah. And you'll just assume that it works. You don't need to look at all the code because your prior experience has informed it. And a lot of the time that's, correct in general, but it will miss out the important details of the implementation. And so in a ACF sense, that's bad. If errors get through at step one and they're not corrected, then what happens is that by the time we're done and we're ready to do an agentic workflow with the database, we're dealing on wrong information. And so this verification step became incredibly important. And so to show the difference between those two repos, I assume you can guess that this dev A had ACF, so which I onboarded it this afternoon. It takes like half an hour. And what it did was it produced this, the architecture, the overview, the system map. So again, this is all standardized. It's an opinionated architecture overview document. So all of them will have this structure. And to my mind, and it'll have code samples. Keep in mind that all of these, depending on the repo, it'll be completely different, of course, and we'll use the conventions of the repo or the language itself. But this document here acts as the system map. And then in that prompt that we did before, it read that document straight away because it's been told to read it. And so what we don't want to do is we don't want to troll the code base because the LLM might hallucinate or get wrong information. So we use this as the map as the starting point. And you can see it's quite specific to the location. We talk about here the testing, the tooling, etc. And the details of this aren't that important. But what it is, it's been generated, but critically it's been verified as well. And so I'm trying to get to this bit down the bottom. And here, here, that's what I was looking for. This is all of the relevant high-level areas of the application, and then the agent's been told to read these particular files. If you've got something to do with, don't troll the code base to understand security and authorization. Read this doc first and use it as a launching point. And again, in that sort of the context, and I'd probably use the word, that's why I chose memory. I see this as an overlap, that we use compute to understand and build out context. But what we're doing is we're also saving a point in time. We're saving all the memory of our understanding. And all of these documents, they've been auto-generated, but they're designed to be confirmed by humans. But I would do that overlap of the idea that context, and that's what's called the Agentic Context Framework, is it's providing the context for agents and humans to work with a code base. But it's also what it's doing is it's acting as the guardrail and the guidelines for memory. So when we make a decision with the application and we have a fork in the road where we go, let's use data layer A or B or whatever, that it's stored. And we've stored that memory, we've stored that context. So future versions of ourselves will be able to use that information. They will have that context, and it's the code, the files are first-class citizens. They're part of the repo, and they're designed to be continuously updated. So I was mentioning that verification. Here, I better do the preview. So when we're onboarding ACF here, it's got the relevant steps, and this is the agent produced this file. So we have, and you can see that we do tag team, Sonnet, then Opus, Sonnet, Sonnet, Opus, Opus. And look here, the corrections. So, we've got a counting error. So it was counting them, there was 10, but it said there's 12, or maybe vice versa. Again, we get a counting error. And so critically, these have been corrected. We picked the verification steps, they picked them up, which is awesome, because that's what we really want. We're all humans are fallible, and LLMs are fallible. But the verification steps within ACF are designed to specifically pick this up. And so we can see stage 3. This one's a really hard one to do. It's like the inheritance chain. And so the verification step picked it identified that the documentation was incorrect, that there was a piece of in the agent's MD, it was wrong. And it said, hey, the base class is this, but that's incorrect. And all of these has been picked up and then corrected, which is 100% what we want. And then I'm looking for here, and you can see this here. All of these have been fixed, they've been resolved. And so that was my lesson from the harness. So when I did the harness, I was going, oh, there's been heaps of errors in those documents. And then that's why I wrote those verification steps. And then I refined it, I iterated, I did the feedback and the feed forward to improve the quality of the particular agent. And so, because it gets a bit meta, to be clear, when the agent, once it's done, the agent has onboarded, it's actually not used. It doesn't need to be used unless there's an update stage where I'm trying to find the stage where over time there will be drift in the, here we go here. So we don't need to run this, but it basically ACF will be told to go over the code base, over the doc, and then detect any drift and then fix it, because that's what we want. We want a stable, correct reference point for agentic workflows to be able to read the documentation as a starting point and then use that to fix or implement the relevant feature that we want it to. And then I do here, I was mentioning, this is a Claude thing. So ACF works on Copilot Codex. And so I have Agents MD, and when you're obviously familiar with it, to my mind now is like the standard. And Claude has their own one, but Claude MD, I just make it a pointer to Agents MD. And then I'm reinforcing that doc. If I ran Copilot, CLI, I would create Copilot instructions, but it would look exactly like this. Because it's pointless to duplicate the same information. And so Agents MD is the primary source of agentic information for this particular repo. And I just I won't go through this all because you would be familiar with this idea, and some of these, I think some parts of Agent MD, not the headings, but the contents of there are starting to standardize. So we have, your build and development, the environment for onboarding for either humans or agents that they can set up. And again, keep in mind that this is all auto-generated. There was no, unless there was information in the README, which would have then migrated, all of this is just derived and then verified by the agent. I was working with my teammate today, and we have code conventions. And part of this information for Agents MD is the tribal knowledge. And an LLM's it's got no idea of the tribal knowledge. So part of the ACF step is to have these, particularly this Agents MD, or if there was another document, is the tribal knowledge, the information that's in people's heads, or is in an email, or was in a PR that's long gone. These tribal knowledge are critically important to be added to the particular document suite, so that the agents and our humans working alongside can then know the actual, this is why we don't do that, or this is why we keep that file name or that particular coding convention.
Andrew.
Yeah, of course.
Sorry to interrupt. There's been some discussions and conversations on the chat.
Yeah.
And I think they are related to what you're saying. Is that we had Wallace, he mentioned about that he's learning, and he's not sure about if there's a limit on the length of the data on markdown files.
Yeah.
Right. So that was his question. There's been another comment from Espinosto that the limit is going to be based on the overall context. And he suggests to experiment with slash context, slash compact, slash clear, just to see how coherent is the conversation. From your experience, did you face any particular issues with markdowns that were lengthy?
Yeah, I do. If you go, I do Agents MD, people say um, around 300
Okay.
is in as a baseline. And
Yep.
it's I would also argue that also it's like RAM and memory becomes cheaper over time. I feel like with greater LLMs and greater hardware, that context will increase. But in answer to the question, yeah, if you do the standard, the OpenAI and Claude, often that figure around 300 would come often again. So
Mhm.
I do for the Agents MD in my the ACF agent. I've got a no more than I think it's no more than 350. And so
Okay.
what the this that the back to that context rot problem is we need to have instructions that it's precise enough for the agent to execute the task that we need it to and follow the guardrails that we require, but not too much. It'll just start to ignore it. It'll just go, I'll skim it and then uh, uh, not pay attention to the particular task at hand. So I did for Agents MD, I did it in the instructions here for the files. Again, the prompt here, if we look in the docs folder, there's a lot, but it's basically instructed not to read all those. Only read based on the task, if that makes sense. So if you're
Mhm.
doing something on caching and signals, you obviously don't need to read all these files. But that particular clogging up the context definitely can affect the output. But I caution and say over time, I'm not suggesting putting 500 or 1,000 lines into Agents MD, but I think over time that amount will increase as the relevant LLMs become more powerful, the context window increases. Like we've seen 1,000,000 now is like the standard, whereas December only Gemini was doing that. Whereas I think what I'm trying to say is that's not a hard and fast limit, and it should be a value that's evaluated, over time, if that makes sense.
Mhm. Yep. Oh, good.
I'll do one last one, the special source here of ACF. This, the retrieval discipline and the thinking behind it around that idea of context management. We don't want it to, and we saw that other in DevB, we saw that example, it trolls the code base and it'll just search and it may hallucinate. So I've got retrieval discipline and it's told the agent, this is so the agent's MD, so ACF produced this, but the idea being is what we want it to do is we actually say these are the rules. Read the PR, read the, that's what I was just talking about before, read the architecture overview and select the relevant one. And then hear this part here. And this is, to my mind, the special source of ACF. What I'm trying to do is we want to identify the entry point to the application. And then all of our applications, depending on the repo, change. And so this part here is all dynamically generated based on the code base. And I've got examples in the ACF. But say this is, I don't really understand this application, but if we look at it, it's basically saying, I find it easy if we think of like a web API, an API project. If you're going to understand the code base, you typically start the controller. And then you go, the service, and then the data layer. And then you'll fix whatever you need to fix. This idea of the retrieval discipline is trying to mimic that. And so in this project, the Orchard CMS, the modules are the starting point. So basically what I'm saying to the agent is, okay, see if there's anything, if for the particular feature that we wanting to do, start in modules, if the prompt or his request related to modules. And same as like the driver CS. But all this step here is will be different per repo, different per code base. But this idea of what I'm attempting to do is to make the agent more efficient. So it goes, I'm doing this, I can just go here straight away. It doesn't need to look, it doesn't need to have to think, if that makes sense. And then I try to, but it's just an instruction. I say, after making a change, update, self-updating. And ideally, the agent may or may not follow that instructions. But what I'm trying to do is give an instruction to say, hey, update the documentation as you go along, be it the architecture or even Agents MD. which is like it's self-updating, or in theory self-healing in a way. If a new change has been made, or if it identifies a change, it can update. And here's this line there. I'm saying it specifically, don't scan the entire code base. It's not a hard and fast rule, it's just the instructions. It's up to the agent to follow that. That idea, and I think the retrieval discipline, is one of the powerful features of ACF. It provides the instructions and the guardrail specific to the repo for the quickest, most effective way of completing a task. And so I'd probably just finish. I might answer a question, but I might just go back to, I won't do sound, but so I produced Clinky. It's got a cool name, and it comes from CLI thinking. Here. It's on NPM, so you can install it via NPM. You need Copilot, Codex, or Claude installed. But what it does is it visualizes the idea. It's the prompt, or the system prompt, is it's categorized thoughts. So we saw that one before. We saw this one here, and I'll just do. I'm in demo mode, so I saved that session. I'll tempt fate. No, I might not tempt fate. I might just change a different. There's 31 different modes, so I don't think we're going to have sound, so you can just sort of use your imagination. But this is the particular thoughts, and in this case, it's just the theme is like a chord. So if you could hear sound, it's actually making unique sounds, and if on the mouse over, those notes are making, so you can play the session. And if I mouse over, these are all the thoughts, and they're categorized. They've actually got a relationship. If you see these lines here, they're all the interrelated lines of the thoughts and the thinking. And then if we go, when it finishes, this is what you're probably more used to, is the interface. So that's all the information about the prompt, but I do a narration layer as well. So each of the thoughts the system prompt is being told, hey, categorize these thoughts, break them up into batches, but at the same time, narrate as well the particular conversation and its execution. And then if I scroll down, we can see here. And so that's the resolution. That was the answer to the question. Build a modular presentation. It doesn't really matter, etc. But then with my favorite parts is this. I tell the model to reflect on what it's just done, and it can get quite meta. But the idea, if you see here, that it's saying, oh, it's reasoning. It had a confident outline. It was never really sure whether I'm the user is the speaker. But it just favored producing something over asking first rather than asking me back. But this part here it's that idea of having a model reflect on itself, and it fits into that theme of an agent thinking, or an LLM thinking. I'll finish. I'll do one more, but I'll just change it. So this is here. And again, you get the idea. It's a visual way of seeing. So these are the little thought. That can be interactive. So some are interactive. I can change I can change the order of particular items. And then to go back to really finish is this. I did, at the same ACF tool that I showed you, I made an inspect tool. And what it's basically doing, this is like my debugging view. And so what I did when I was developing Clinky is I wanted to get the information. I wanted to see all the relationships. So this is that same prompt. And if you look at all the different, it may not make any sense, but it's all the categorization information. It's how Clinky is joining the thoughts together. And what it does then is it produced this JSON down the bottom here. And then I could get that JSON, I could paste it into the Claude and say, hey, it produced that. And then we refine the system prompt, or we define the relevant information about it. And then when I was doing it, what I need to do, again, in that feed forward and feedback, is I would run it in Codex. I would run it in Copilot, and I'd run it in Claude. And I'd do the same prompt. And then that way we could analyze the way the different LLMs were interpreting the same prompt and tailor that particular the system prompt that's driving Clinky. I might just look here if there's any comments, a whole bunch of so if there's anything I missed or Marcel for.
No, I think like there's been just comments, but not necessarily
Yeah,
questions.
cool.
And I
Yeah,
think like the crucial ones like we raised like during like when you were
yeah,
presenting and bring the
yeah.
context. Yeah.
Cool. Cool. So I think that's about it. I might just put in, I might share that with you, Marcel, with the link.
Ah,
But you've got,
yes, that's something that the people have asked, like for
yeah,
links. So I put the repository link
yeah,
I shared
totally.
on the
Yeah.
comments. I don't know if there
And so
are
that,
others that you'd like to
yeah,
share.
yeah. And you can see that this is just my repo. You can see that Clinky's there, got released on NPM last night. And yeah, so you can just NPM install. It's without even, I think there's just bots all over NPM, but I released this last night and there's like 621 downloads already.
Yeah,
And so I assume it's bots because I'm going to put it on Hacker News tonight or tomorrow morning.
yeah.
But yeah, so you can just do npm install. You've got to have Copilot, Codex, or Claude installed. But yeah, all it does is it's a wrapper over a Node.js. It's a wrapper over the CLI. It has the system prompt that guides its thinking, and then we just have this nice UI. And I will flag in sort of in summary, none of these, there's no dependencies. And I think particularly for NPM, it's not a bad idea. And that's one of my themes. So like Clinky, there's zero dependency. There's nothing. So the front end and the back end are all just vanilla. There's no NPM, or whatever. And so that would be some of my themes in all of most of the work that I do. I really try to, unless the tool's like a must-have, to reduce the dependency. So Clinky has got zero, which I think is quite a good feature.
Mhm. Yeah, pretty cool. Yeah. I like the colors and the graphs.
Yeah,
Yeah, pretty cool. Yeah.
cool. Well, that's about it. Me done. I think hopefully I didn't speak too fast, but yeah, hope you got some information about that. And yeah, that's it.
Yeah. I learned, right? So feed forward, feedback,
Yeah,
memory,
yeah,
harness, all
yeah,
around what LLMs that you're using.
yeah,
That was really interesting because you
yeah,
combine like information that you got like from different resources, right? Anthropic and what's
yeah,
happening in the latest news, like or findings, right? That
yeah,
are being raised by the community, and you brought like some really great insights. I hope like people take like your framework and leverage in their own solutions. There was like a
yeah,
comment, I think, from someone saying that, oh, I'm doing exactly that. So I'm just going to explore. So
yeah,
that was like
totally.
a comment about
And
that. So
I
it's cool.
forgot to say at the start that all of this, everyone's trying to solve similar problems at the moment. This
Hmm.
context management, memory management, um,
Yeah,
uh, making repos ready for an agentic workflow. So
yeah,
yeah, this ACF is not a unique idea, but yeah, everyone's sort of rushing to try and get some, common ground, I think.
yeah. That's true. Yeah, I think like uh, so we're trying to solve like similar problems, and then let's see what happens, right? Up
Yeah,
to a couple of
exactly.
months ago, things well that wasn't there, right? So it just came up with like this sort
Yeah,
of idea implemented. So what's going to happen in 6 months' time? I think that's a question
exactly.
that we don't know
Yeah,
yet, right? So
agree.
yeah.
Yeah.
Well, thanks so much, Andrew. I appreciate like
Yeah,
your
no,
your time, you being available, and coming to share like this great insights, and inviting the community to leverage something that you're just sharing, right? Putting like as open
Yeah,
source.
exactly. Yep.
And yeah, I don't think like we're gonna have like additional questions, but yeah, I think like with that, we're just like finishing the session.
Yeah.
And yeah, again, Andrew, thanks so much. Appreciate like
Yeah,
your
no, it's
time.
a pleasure.
Yeah, you're welcome to come back. Maybe at some stage, if the
Yeah.
market changes and you come with improvements,
Yeah.
for sure, like people are gonna look at your framework with like an approach and perhaps even create like pull requests, right, or something
Yeah.
that they want like new
Yeah.
asking for features and
Yeah.
contributing. I think
Exactly.
that would be cool.
Yeah, totally. Yeah, I'm working on behind the scenes like version X of ACF, sort of a massive uplift of it actually. Um,
Yeah.
but yeah,
So yeah, people have
cool.
your contact, and yeah, with that,
Yeah,
thank you again for the audience, and keep in touch. We should have like more sessions coming, and it's all on Meetup. And yeah, I appreciate it for you staying with us, and catch you guys later.
no worries. Thanks all. See you.
Thank you. Cheers.